Okay, good morning, everyone. It's good to see you all. I am recording this morning, and the folks who gave me their homework, this is great, but make sure before you leave here I give you that back, okay? And the first thing I want to do is just start off by asking, are there any concerns? Is there anything that you're not making sense of? Is there anyone who's not yet enrolled in mastering or having any issues with your resources, the bookstore out of any resources, anything at all? Question?
It's not really a question. It's like, do we need like chapters? Do we need to read them in full and know the things before we come to class, or just like skim over them?
I would recommend that you skim over the material before you come to class, and then if I discuss it in class, then it's something you want to go back and look at again in your book. Do that. If there's a topic that I don't discuss in class, I'm not going to. It will not be on the test. Okay, so if you come to a section of the textbook that I have not discussed, it will not be on the exam. So you can check with me, but you can be with great confidence sure that if I didn't talk about it, you can skip over it.
For the pre-lab homework, I clicked on the pre-lab, the homework 1.
Yep.
Lab homework 1 or whatever, and it had like 2 parts to it.
Yes, so there are 2, let me go to mastering in a few minutes and answer questions looking at the calendar, so hold on to that question.
Okay, for the mastering A&P, for the pre-lab assignment, what's his name, Mr. Keith, told us if we have trouble with the email, I went onto my courses under sources and I'm not able to find pre-lab.
After class, let's do it. Let's talk about it right after class, okay?
He told me to give this to you.
After class, okay? So any concerns that I can deal with right now publicly, if you have a personal issue, we can deal with it after class. Anything, everyone's got a supplement, no shortage in the bookstore, everyone's on mastering.
Yes. Okay,
I've been very, very pleased. I've got to tell you, never have I had 160 students get enrolled in mastering and not have issues. And I think it comes down to the fact that you actually read my emails, followed the instructions. Thank you. Question?
I actually don't have my supplement yet because I have to get mine from Fremont because I'm part of the today, so my books were
Understood. Okay. So very good. Yes.
I know the assignments. Some of them still have dates from 2000.
Only worry about ongoing assignments. So on the calendar, ignore anything that's past due. There's nothing past due. Look on the calendar for future things. The assignments that you're seeing that were due back in the summer are just that from last summer's course, and they will be replaced in the calendar as appropriate. So don't worry about anything back in June, July, August, early August.
So when you log on to Mastery and it has like a little pop-up that when you download, you actually download some things, but it says you did download.
Yeah, so your computer, when you log into mastering, each and every time, it is going to do a quick check of your resources in each sermon if you are missing anything. And then it's going to give you a link to download updated versions of Chrome or updated versions of Firefox or Shockwave or whatever the issue is. Usually that holds just fine. So if you keep getting the error but everything seems to be working okay, just click on the bottom. It says ignore this message for 30 days and you'll be fine. Okay? Anything else going on? Mastering. My readiness test? I've had a couple of issues, but only a couple very isolated issues. So that seems to be going very well as well. Question in the back.
So far on the mastering thing, all we're supposed to do is the readiness test, right?
That was separate. That was totally separate. You have your pre-lab number 1 assignment. Let me go to the mastering calendar in a moment and clarify that. There's the pre-lab number 1 assignment that was part of your lab, and there's an assignment due by Friday on the introduction to mastering.
Okay, the readiness test, those are 2 separate things.
2 separate things. And my readiness test is a completely different login, separate issue.
And when I went on there, I tried to attempt it 3 times. I wasn't able to the first 2, and I logged in again, and it won't let me.
No, you can only take it once. So if you logged in and it timed out or something, the only way around that is to go back to myreadiness.test.com and re-register as a new student using a different email address. So use your Gmail or Yahoo account.
But it says that my computer doesn't have the software to.
Well, then that's a computer issue. I would suggest doing it on campus. Okay. Other question?
Is the homework like online? The homework we're supposed to turn in Friday?
It's all on mastering. Just to click on and do the assignment, and it will record the grade automatically. Okay, let me continue moving through this. There's one thing I did not mention on Monday. There is an honors option available for Biology 105 if you're interested. And there are some criteria that are necessary for you to be eligible for honors courses. And honors courses at MCC work a little differently than most schools I've been at. Basically, for the way I do it, there's another book that you read and some critiques that you provide and a small research article or paper that you complete as part of your honors credit. You pay for an extra credit, and if you get a B or better in the course, then you get that money back. It's basically a free college credit. You don't get that anywhere else. And it's a Christmas savings plan. You get your money back in December. And but I usually tell students, if you're interested, take a look at this. But you don't necessarily have to commit to this until after the first exam. I don't want anyone jumping on mastering and then, jumping on honors and then realizing, man, I really have a busier semester than I thought. So I want you to wait till after the first exam, determine your workload, your class load, whether or not you can handle an extra little bit of work, and then talk to me. But this is available for you to pick up on the way out. There's also a copy of that one-page syllabus on Blackboard under lecture materials. You'll see a link to the honors syllabus there as well. So talk to me about that if you are at all interested. There's nothing due for honors until well into the second exam. So there's no rush on that. Think about it, talk to me, and then make a decision. Okay, let's go back, as I always will do with you, let's go back to vocabulary. And you know that on the first exam, we're going to have vocabulary slides 1 through 16. And I went with you through the first 4 slides on Monday. Let's go 5 through 10 today. Remember that all you need to know is the prefix in bold on the left and the definition or the meaning that's also in large bold print. The example underneath it is just simply that, an example. So you just need to know that AN means without or lacking. It was the same as A, wasn't it? So we've already seen this. You can put it on the same card. In fact, we did this last time, didn't we? So I actually owe you 6 through 10. So let's go over to 6. This is where I dropped off last time. So ante means before. Antepartum, before birth. Where else have you seen ante? In lab already this week, if you've had lab. Antebrachium, before the brachium. Okay, so that's another place where you've seen this term ante. Anti, against. An anticoagulant is a chemical that helps to prevent blood clotting or coagulation. Apo, separated from, and APS or APT both mean to fit or to fasten. If you look at this word synapse, and we'll talk about this word a lot when we get to the nervous system. A synapse is where 2 cells come into very, very close proximity, almost touching but not quite. So they are fitting together, and SYN means together. So synapse means literally 2 things coming close together and interacting with one another. AR, you've already seen A, right? And AN and AR, all 3 of those mean without or lacking. So you can go ahead and put them all on one card if you wanted to. Now tell me, who has already made their cards? Good, okay? And the rest of you are going to do it soon, I hope. What I don't want to have happen, and it happens every semester, but I can't seem to stop it. There'll be a student who will approach me somewhere around the 3rd or 4th exam. They will have done poorly on the vocabulary, and I'll ask them, what can we do to do better on the vocabulary? And I'll say to them, have you been making flashcards? They'll say, oh, that's a great idea. Yeah. So let's go ahead and make them now, right? I assure you this is the best way to learn these terms, and go through that little flashcard set once a day, and when you get to the exam, you will not be stressing out or worrying about the vocabulary. You won't be using up other important study time to worry yourself with the vocabulary. Arche, origination or beginning of something. Menarche, the first menstruation. Arthro, joint. Arthritis. Itis is inflammation. Arthritis, inflammation of the joints. And then the next term, I have a typo on it, and I apologize. There's no R. There's no first R. It's atrio, not artrio. Atrio. And it means entryway. Your church, your home, you may describe the entryway as being the atrium. And the heart has an atrium, and it's where the blood first enters into the heart. Airy, associated with. So urinary, associated with urine. And if you see a term that ends in ASE, it is almost always, I can't think of an exception, that term is almost always an enzyme. We won't quite get to enzymes today, but we will talk about enzymes next Monday. Enzymes are biological catalysts. So as example, if you see polymerase or kinase, again, you don't need to know what those mean, but those are examples of enzymes. If a term ends in asis or asia, it's some sort of condition or state of. Homeostasis. We'll talk a lot about that today as we get started with the rest of chapter 1. And it's a state of keeping things rather rather similar or same. Asthen, weakness. Myasthenia would be a weakness of muscles. Athero, fat. If you look at the example, atherosclerosis. Sclero means hard. And so it's a hardening of the arteries by a buildup of fat, lipids. Audio, hearing, ari, ear. The auricle is the flappy part of your ear. Your heart also has auricles, these flappy structures on the outside that are ear-like. Auto means self. Automobile literally means to move yourself. Autolysis, some cells break themselves down, and we'll talk about that process as we move into chapter 3. And then finally for today, baro, bariatric surgery, surgery to lose weight, or a barometer, an instrument to measure pressure. Beni, good or well. If you are giving a benediction, you're giving a good word. If you hear that you have a benign tumor, that's also good news. If you're going to have cancer, that's the kind you want, and that's likely not going to kill you. We'll talk about cancer in chapters 3 and 4. Bi, twice or two of or double. Bicuspid, teeth with 2 points. You have a valve in your heart called the bicuspid. It also has 2 parts. And then finally, life, life. We are in a biology class. We're studying an aspect of life. Ology is the study of life. Biopsy, right, would be taking out of living by life. Opsy, viewing. You're viewing living tissue when you take a biopsy. We're going to continue with the vocab. I'll probably do all 6 slides next time, just that we're done with vocab for the first test. And the first test, again, is slides 1 through 16 with 0, going through 16, going down to 0, which means yellow. That'll be the content for the first exam. The vocabulary is not cumulative. I wish it was, but I've not made a decision to make it cumulative. So it is just simply exam 1 will have 1 through 16, exam 2 will have 17 through 32, or whatever the number is. So just know it's going to be kind of chunked up. Now, that isn't to say that this won't help you. As we move through the course, the vocabulary will assist you in learning terms as we move through, but I will not directly quiz you on terms outside of our little section for each exam. Okay, so let me take a look at mastering with you just for a moment and solve a couple of the mysteries that you are having. In fact, I probably should back up out of here one more level and make sure, is everyone seeing Biology 105, 2015, fall, Macaulay, with a bunch of numbers after it? If you can see that, and I believe on your side, you see Dr. People's face.
Yeah.
They're fixing that. Unfortunately, soon you're going to see my mugshot. There was some internal glitch. And unfortunately, my face will be looking at you soon, today or tomorrow. That should pop up. Thankfully, I don't have to see it when I log in. So if you see that, you are enrolled. And when you click on that, you know what happens. You go to the Blackboard site. Now, on the Blackboard site is where the announcements will be. It's where all the lecture and the lab materials are. It's where you go to get the YouTube lectures, right? So once I finish this lecture, I'll be uploading this to YouTube, and you'll be able to hear this entire presentation presented to you there as a review. And then under Mastering AMP, it sounds like all of you are successfully enrolled. When you click on Mastering AMP, it brings you to a series of green boxes. I can't change this group of options. The one that I'm going to insist or encourage you to click on, though, is actually at the very, very bottom, and it says Course Home. If you click on the one at the Course Home, you will actually get the greatest number of options. Okay? If you click on just the e-text or just assignments, you may not see everything available to you. So go down to the bottom and click on Course Home, and now that will bring up, Course Home will now bring up this. And it will bring up the entire calendar, and it will bring up the options over on the left-hand side. I'm going to go back to August. You can't see everything that I see because I put things on here that are not yet available to you. But what you are concerned about is only assignments that are from this point on. The date that we're dealing with is right here, the 26th. By tomorrow, all of you will have had lab, and all of you will have completed pre-lab number 1. Pre-lab number 1 was 21 questions. It was worth a maximum of 2.1 points. It counted out of 2, so if you got a perfect score on it, you got a little extra bonus on your pre-lab. Now, where do you go? Once you finish that assignment, what are you going to see on your calendar? Once you finish that little assignment, you're going to see a little green box right there that says little check mark. You know that you have finished that assignment. Once you have finished that assignment, now you want to tell your lab instructor what score you got on that. Include that on your yellow pre-lab form. You're going to go over to scores, okay? On the left-hand side. I can't go there because I'm not enrolled as a student. But click on scores over here on the left-hand side. And then you got to do a little searching. And I apologize, it's a little bit awkward. But you're going to scroll almost to the bottom. And at the very, very bottom of all that, you're going to see a grade, pre-lab number 1, something out of 2.1. Whatever that score is, which you're going to plug into your pre-lab form. You're going to see a pre-lab assignment like this week after week after week. So get accustomed to doing it. So you're going to make sure that you do that pre-lab assignment before you come to lab. Before you come to lab next week, you should also do lab 1 homework. Some people have done the lab 1 homework thinking that was the pre-lab. Okay? That's a different assignment. It's basically a post-lab assignment, and that assignment is going to help you prepare for your lab quiz next week. So even though it's on the calendar for Thursday, you should look for that assignment and do it before you go to lab. If that's Monday, Tuesday, Wednesday, or Thursday next week, you should do that lab homework assignment before you show up. You're not going to tell your instructor your score, but those points do go toward your overall mastering homework grade. In addition, next Tuesday is the homework. It's due. You can start it now, but it's due. So there's a Chapter 1 homework assignment. That is also part of that big mastering homework grade that you're going to get. And before it, over here on the 31st, is an orange-colored assignment. This is a dynamic study module. It's a different kind of homework assignment, but it's also a required homework assignment. So you've got a couple things coming up in the calendar. Let me just click on that dynamic study module so you see what this is. It's a different type of assignment. When you click on it, you're going to see a series of questions. Every one of you will have the same questions. You're given the question, and then you're given a series of choices. If you know the choice, if you know it with confidence, I'm not reading the question, so don't judge me here. You just double-click on it if you know it for sure. And then you go to the next question, submit. The next question, I was wrong. Oops. Okay, next question. Here's the question. I don't know if it's this or this, so I can choose 2 different choices. Next. Okay, not doing well. Another question, I don't know yet. That's okay. Click on it and move forward. So you go through about 6 or 8 of these questions. Ooh, one of them's right, one of them's wrong. It doesn't tell me which one is which yet. I think it's that one with confidence. Ooh, lucky guess. Okay. And what's going to happen here, don't do this. Do it right, okay? But after about 6 or 7 questions, it's going to say, let's go learn. Okay, let's go learn. And it's now going to go back and review the questions that you had. It's going to show you on the bottom exactly what you needed to look at in your textbook to understand that question. Okay, fantastic stuff. So everyone in the room will do this assignment. You're graded on completion. You're not graded on how well you did, how correct you were. Everybody in the room will have a slightly different experience with this program based upon your right and wrong combination of responses. But you will get full credit as long as you complete the deck of cards, the deck of questions, okay? So it's not something you need to worry about being correct or wrong. And by the time you go through this, you will learn new material. This dynamic study module program is available on your cell phones. So I think on your side of mastering, there's a thing that says you can click on it and go to your and download an app. And then you can actually do these dynamic study modules very easily on a smartphone or a tablet. You don't have to be tied to your computer. Question?
Does it keep giving you more questions?
Same set of questions. The questions don't change, but you have to get it right twice before it goes away. So it's going to force you to get the right answer, know it or not. You're going to know the right answer, okay? Question, other question?
When I click on the Mastering A&P course home, I don't get a calendar.
Okay.
But if I click on Welcome to Mastering
but you only get the calendar and you don't get the things on the left-hand side.
Right.
So we need to figure that out. We'll look at it with you afterwards. Okay? You should get the whole calendar when you click on that. Any other questions about mastering? Great. Okay. Come see me if you're having any specific concerns. Now, let's go back to our presentation. And as I recall, we didn't get very far, did we? No. We got through, kind of read through some study. We got through the short history. And I got to here, didn't I? And what did I call this image? Atom to atom. Yay. So I'll be referring to this quite a bit. And I was going to fill in a couple gaps here, wasn't I? So let me go through this with you. And there's two, I'm going to put a star right here. There's two extra levels of complexity that I'm going to mention to you that are part of that line and part of that star on the left-hand side. So here's the deal. As we go through this hierarchy, the lowest level is the atomic level. And all of the elements on the Earth are made up of these atoms. And here you see a periodic table. You don't have to memorize this table. You don't have to become a chemist at all in this course. There happens to be a periodic table over here in the corner. I'm not going to pull it out. But basically, we'll understand what these atoms are before we start here. And this is the lowest level that we'll discuss. Those atoms, things like hydrogen, carbon, nitrogen, oxygen, are then the building blocks to make molecules. Molecules would include things like H2O, right? Simple enough. H2O, what does that mean? Water. 2 hydrogens and 1 oxygen have combined together to make this molecule called water. Or CO2. 1 carbon and 2 oxygens have combined to make this molecule called carbon dioxide. And other small molecules like sugars and vitamins are also considered molecules. And there's plenty of them. Now, those molecules now become the building blocks to make the macromolecules. And there are 4 groups, 4 types of macromolecules. Most of these are what you find on your food product label. So when you turn your label over on your food, what does the manufacturer tell you that's in there? What molecules are macromolecules? Proteins, right? You're going to be proteins, carbohydrates. I'm just going to call it carbs. I heard lipids, yes. Now, do you agree that's the fats and the oils? Do you agree that those 3 are on your food label?
Yes.
There's one more that's not on your food label, but you do consume. Nucleic acids, right? DNA and RNA. Do we eat DNA and RNA?
Yeah.
Absolutely, right? Lettuce has cells, so we're eating DNA from lettuce. So absolutely, we're consuming nucleic acids. It has no nutritional value, so we don't put it on the nutrition label. But those are the 4 types of macromolecules. So proteins, carbs, lipids, nucleic acids. 4 groups of macromolecules. Now, those macromolecules are the building blocks for another missing link, organelles. Organelles are the little factory sets that are found within cells. Things like the Golgi, mitochondria, cell membrane, nucleus, lysosome, and the list goes on. And we'll look at some of these organelles. We'll look at their functions in the next chapter. But for now, we're just kind of learning this hierarchy. So the organelles are the little building blocks of the cells. Now we get to the cells. The cells are the most fundamental living thing. They are the smallest living thing in your body. And there are in your body roughly 250 kinds of cells, and there are over 75 trillion cells in your body. Okay? So you got 250 different kinds of cells, numbering somewhere in the 25 trillion range. And those are just your human cells. There are 10 times more bacteria in and on you than there are human cells. So as a walking organism, you are more than just human cells. You're actually 750 trillion bacteria in and on you. Kind of gross, but that's the reality. So cells. Now, the cells become the building blocks for tissues. Tissues are groups of cells that work together in a collective purpose. And there are 4 basic types of tissues. When you're studying tissues, what do we call that? Histology. When we're studying cells, we call that cytology. So there are 4 basic types of tissues as well. And we're going to spend a lot of time this semester looking through the microscope, learning what these tissues look like. In no particular order. The first group of tissues, the first type of tissues are the connective tissues. This includes blood, bone, fat, cartilage. There's a whole bunch of them. And we'll learn what each of them looks like under the microscope. We'll talk a lot more about them. Then there is muscle tissue. It turns out there's 3 different kinds of muscle. The details of this is not yet important, but skeletal muscle is a kind of muscle attached to your skeleton that causes your body to move. Smooth muscle is a type of muscle around your gut, around your blood vessels, and is moving things outside of your control. And then there's cardiac muscle, which is also not of your control, which is running the contractions of your heart. And we'll deal with those. We'll see what they look like. We'll know a lot more about those muscle types. Also, there's epithelial tissues. Epithelial tissues are the ones that cover our body. Your epidermis is epithelial, as is the layers that cover your organs and the layers that line your gut tubes. Boy, that sounds like what? Those who've been in lab. The serous membranes, the pleura, the pericardium, the peritoneum, right? Those layers, when I talked about those serous membranes with the visceral and the parietal layers, those are epithelial. Okay, so that's, when you hear epithelial, it's some sort of boundary, some sort of border, something that lines and coats and covers. And then there are nervous tissues, and these are primarily found in the brain and spinal cord, but they're everywhere. And these nervous tissues are allowing electrical signals to travel very quickly, to allow you to interact with your environment and to quickly make responses and memory and all of those good things. And we'll be dealing with all of this in far greater detail. Now, what do those tissues combine to do? Those tissues combine to make organs: heart, liver, brain, kidney, stomach. If I had a heart in my hand, somewhere in that heart I could find muscle, connective tissue, epithelial, and nervous tissue. If I had a stomach in my hand, I could find muscle, connective tissue, nervous, and epithelial. So you just combine these tissues in a different way, and now you have different organs. Those organs are now the building blocks for the organ systems. Respiratory, reproductive, you name it, the system, all the different organs that are putting together to make those organ systems or body systems. In your body, there are 11 organ or body systems. If you count 2 reproductive systems, there are 12 that we'll be studying throughout the semester. And those 11 organ systems are combining to make you, right, as the organism. So let's go through these. Now, this looks really familiar. If you've already been to lab or are heading to lab, no surprise. The first quiz that you're going to have is simply recognizing these organ systems. Your job, recognize it visually, know the organs contained within it, and know the function, the basic function of these systems. Now, we're going to go back and study each of these systems in greater detail, but to have a basic understanding. This is the integumentary system. All you're basically seeing is skin, and it also includes the hair and the nails and the sweat glands, for example, on your body. Not only, though, is it providing protection, it's also the site of your nerve endings for feeling. It's also where vitamin D is synthesized in your body. So there are a lot of things going on here that are involved with your integumentary system that are maybe not obvious at first glance, but we'll learn this later. Now, I want to warn you that on the first test, or help you actually, not warn you, but inform you that on the first test, this is not going to be a lot of writing on the first test. I'm not going to say to you as an essay question, write down the 5 functions of the integumentary system. No, it's going to be multiple choice. So it's going to be which of the following is not a function of the integumentary system, or which of the following, all of the following characteristics are of what system. So that's the way you need to be kind of studying this and mentally going through this material. Skeletal system, pretty obvious when you look at it. Not only is it giving you structure and form, but it's also where your blood cells are made, a process called hematopoiesis. And this is where your body stores lots and lots of calcium and phosphorus. It does work, clearly, with the muscular system to allow movement. But I want you to break this down. Skeletal system is bones. It is protection and support, whereas the muscular system is the muscles. And the muscles are unique in that they move, right? Not only does this allow you to move your body, but also, when you're cold, you get up and move. And that helps generate heat. So you're creating heat and also providing movement to your body. Nervous system, when you see this, you should be struck by the color yellow. Yes, sir? Ligaments are also in the skeletal system is the bones and the things that hold the bones together, and so that would be the ligaments would be in the skeletal system. Thank you. The nervous system, yellow, 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 yellow. So we're looking at yellow nerves, and we'll learn many of these nerves' names this semester. And we also notice the brain and the spinal cord here. Endocrine. If you look at this figure quickly, you might glance up and see a brain and say, oh, that's nervous system. Or you might glance up and just see the heart and say, oh, that's cardiovascular. Or look up and see the stomach and say, oh, that is digestive. Or see the reproductive organs. And you'd be wrong. Right? Collectively, all of these organs work together to provide hormones. And collectively, these organs are part of the endocrine system. Endo means within. Crine means to secrete. So all of these systems are secreting into the body, into the bloodstream, hormones. And those hormones are hugely important in maintaining homeostasis, something we'll be talking about in a few minutes. Cardiovascular, red and blue, arteries and veins, plus the heart. Pretty obvious. Not only are you pumping blood, but don't forget that when you pump blood, you're also pumping oxygen, nutrients, hormones, waste products, and all of the other products that are traveling through your blood. Lymphatic, universal color in most anatomy books, green. These are not green blood vessels. These are green lymphatic vessels. In addition to the lymph nodes, there's also tonsils, the spleen, the thymus, a number of other organs and things that we'll learn about as the course moves on. This is why having colored pencils is important. Green for lymphatic, red and blue for arteries and veins, yellow for nervous. I would definitely recommend that you have a basic 8-pack of colored pencils, right? So that when you're doing pre-lab activities and labeling things, that you're able to do so with more traditional colors. There's nothing wrong with green and purple hearts, but red and blue just make more sense. And you'll find that just helpful as you go through.
For the test, do we have to know all of the organs or just the main?
For this test, now main organs, recognize, right? I'm not going to say list the 16 structures within the digestive system. That's later, but not now, okay? Not now. Respiratory system, couple lungs, trachea, all that good stuff, exchanging gases. Digestive system, all the organs that allow you to bring in food and break it down, digest it, and expel the waste products. Urinary system, a couple of kidneys. The ureters are the tubes that carry that urine down from the kidneys to the bladder, and then the urethra releases that urine from your body. You're filtering the blood, you're getting rid of waste products, toxins, things like that. And then we have the reproductive systems, male and female. Here are the testes for the production of sperm and reproduction. And don't forget, the testes are also hormone producing for testosterone. So they're both endocrine and are involved with reproduction. And then female reproduction system, this includes the breasts, and this includes the production of eggs and the development of the embryo and the fetus. So those are the systems. And again, what you need to do, and I think we've already got this down pretty well, but recognize them visually. You're doing this in your pre-lab. You're doing this in your quiz this week in lab. And then know the organs and know the function of those systems. We'll start off easy, and we'll ramp up as we move through our understanding of these systems. Any question on recognizing or questioning functions of these systems? Yes, ma'am.
I have like a question about the urinary system. So since the testes produce their hormones, if they lack those hormones. So if they don't have two, and they may only have one.
Yes.
Should they get some to produce more hormones?
So the question is for the male reproductive system is if a male only has one testis,
Yes.
it still produces hormones and life will go on.
Oh.
Yeah, just like one ovary. There will still be enough hormones. Typically, there's usually going to be enough from just the one, but if necessary, they could always do some supplement from the doctor. But typically, one organ will make up the difference. Okay? So what do all these 11 systems do? They combine to make the organism. Now, and this is being a human biology course, this guy or gal down here on the right-hand side is the organism we're talking about. But this is true of any biology class. if it's a killer whale, a bumblebee, a flower, or even simple organisms like a paramecium, all of those things really are designed in a similar way. Now, clearly the paramecium is not as complex as we are, but still the idea of complexity and levels of complexity are still true for all living organisms. Now, one of the key things, one of the key concepts in physiology is this idea of homeostasis. Homeo, similar. Stasis, static, keeping things the same. So really homeostatic, it really is two words that mean the same thing. Homeo, keeping things kind of the same. Static, keeping things kind of the same. Asis, a condition of. So we're trying to keep everything inside the body the same. You know what? If it was keeping it the same, though, we would call this homostasis. It's not homostasis, is it? It's homeo. Homo means same. Homeo means similar. It's a slight difference. But if it was homostasis, that means that your body temperature would never fluctuate. It would be always the same. We know it fluctuates. Your blood sugar would never fluctuate. Your blood pressure would never fluctuate. We know that these things are fluctuating. If I use temperature as an example, no matter how cold it is out in February in Michigan, or how hot it is in the tropics in the summertime or year-round, your body temperature tries to stay pretty constant, right? 98.6 or so. So the idea of homeostasis is that no matter the external environment, your body will try to keep the internal environment as constant as possible. The body is going to use a process called negative feedback to maintain homeostasis. And I'll come back to that in a moment. And when your body can no longer maintain your blood pressure, can no longer maintain your body temperature, can no longer maintain your glucose levels, then you have a disease. Right? So in this course, we're talking about normal physiology. What is normal? Keeping things within the normal range. But after this course, you'll move on to pathophysiology courses where you study the processes of diseases. And so you'll learn that when the blood sugar can no longer be controlled, we now call that diabetes. When the person can no longer maintain their blood pressure, we have hypertension. When they no longer can maintain their body lipids, they've got lipidemia or some sort of issue with their lipids and their cholesterol levels. So the body tries to do this. Now, the last point on here I want to amend. Some books, some authors, some instructors might suggest to you that all of the body systems are working together to maintain homeostasis, and some would say except the reproductive system. It is true that one can go on through life without reproducing, but it is also true that the reproductive system, hormones, the testosterone, the estrogen, the progesterone, are a very normal part of life. And without them, life is not the same. So I'm going to argue that all 11 systems are necessary for maintaining homeostasis and normal life as we know it. So kind of cross off or make an exception to that statement. All of the body systems are working interrelatedly to maintain your homeostasis. So as a biology course, I don't care what biology class you're taking, a zoology course, a botany course, a human biology course, a microbiology course, somewhere in the first chapter, it is going to say, oh, welcome to this biology course, and it's going to list what life is. It's going to try to attempt to give you the characteristics of living things. This is one of those lists. Every book will have a slightly different combination of terms, but basically alluding to the same features. So all living organisms are organized. Most are made of many, many cells. Now keep in mind, bacteria are one cell. So some organisms are just one cell, but most organisms that we think about are going to be multicellular organisms composed of many cells. Number two, all living things are going to have a metabolism. This is a fancy way of saying every organism is going to take in energy and use it in some way. Every organism, every living thing is going to respond to its environment. Plants move toward light, right? We move away from pain. So that's normal. Every organism is going to grow, have a life cycle, is going to develop. And every organism is going to likely reproduce to make more of themselves. And along this process of life, will be maintaining their internal environment, that is, maintaining a homeostasis. So in the atom-to-atom continuum, what was the basic living thing? The cell. So not only are you a combination of 75 trillion cells, but each of your cells is itself living, and therefore each of your cells must also have these same basic characteristics of life. So it is true that all of your cells are regulating their own internal environment. Every one of your cells is taking in and using energy. That is, every cell has its own metabolism. Every cell is responding to its local environment. Every cell is developing and is maintained and made of complex structures like the organelles. And most cells, I won't say all, but most cells are going to divide to make more of themselves. Does anyone know an exception to that? What cells in your body do not make more of themselves once they're damaged? Nervous system, yeah. Neurons, this is why brain damage is so devastating. Once brain damage occurs or nervous tissue is destroyed, it does not regenerate. Okay? Cardiac muscle. Once someone has a heart attack, those cells that were once contracting to pump the blood are not going to magically replace themselves. This is why, MIs, myocardial infarctions, are so devastating.
Is it because, like, the job they do is so complex, or is it just...
The job they do is so complex, and they just simply don't have the mechanism. I'm not going to go into it right now, but, for example, neurons don't have microtubules. They can't do mitosis. They can't divide. They just simply don't have the machinery. And we'll talk about some of the reasons as we go through the course. Other cells that don't divide and make more of themselves. Reproductive cells, egg and sperm. They don't magically make more of themselves, do they? So this definition of requirements for life is not perfect. It's not black and white. There are some exceptions to this. So what I would say is that most cells have most of these characteristics, but there are some exceptions. So considering that, this is a chicken egg you bought at Meijer. Maybe you cracked it this morning for an omelet. Is that living? It's a cell, right? I mean, egg birth, whatever that company is, doesn't put it on there just to put eggs. It doesn't say egg cells. But these are cells. Do they have all the characteristics of life? No. No, but is it a cell?
Yes.
Yeah, okay. Can't respond to its environment in a much meaningful way, right?
No.
The egg's not going to move over toward a warmer spot. How about sperm? Are they living? Yeah, they wiggle. They must be alive. How are they any different than an egg?
They have a living host.
Say it again.
They have a living host.
Sperm can't reproduce on their own. They do respond to their environment. They are heat-seeking missiles, and they move toward temperature gradients, and they do move toward chemicals. But they're no more able to reproduce than an egg. So are they living? There's no right or wrong answer. It's a discussion. Okay, so I'm not going to have you write, a long 500-word paragraph thesis on is a sperm living or not. But I want you to just think about it, that yes, it's a cell, but it doesn't have all of the characteristics. By itself, it can't reproduce. Red blood cells don't reproduce. Once you make a red blood cell, they don't make copies of themselves. They don't have a nucleus. And so there are exceptions to the rule, but they're still cells. And you'll still hear the word egg cell, sperm cell, red blood cell. Question in the back. Okay. So just kind of a thought. Just a thought. So I mentioned the word homeostasis. And I said that the body maintains homeostasis through negative feedback. Let me describe what that is. And I'm going to use a thermostat in your home as the example. But you could be thinking about blood sugar levels or other mechanisms as well. Negative feedback is basically this. When the temperature begins to rise or when the temperature begins to go down, the body has a way of pushing it back to where it should be. It has a way of resisting the change or making that change smaller. So if we think about a thermostat in your home, there's a receptor. There's something that measures the temperature in your house. There's also a control center, the thermostat. And what the thermostat is doing is it's comparing the temperature that it's reading with the temperature you set the house to be at. And it's comparing constantly how is the temperature in the house comparing with the temperature you told it to be at. And then finally, there's a mechanism when the change is dramatic enough, it will change the value. The heater will come on or go off based upon what's going on. So let's look at this at a visual representation of this. Across the middle, we could call this the set point. Okay, this could be called the set point. Another way, this is where you set your temperature. Set point. Let's say it's 70 degrees. So you set your thermostat at 70 degrees, and that's the dotted line. That's the optimal environment. It's winter time, let's imagine. And so what happens? We got leaky windows, leaky doors, and so the temperature begins to drop. At some point, though, what happens? The temperature in the room drops. The thermostat is set at 70. It's dropped so low that something happens. What's going to happen is the heater's going to come on. That in your body might be a hormone. Is released. Something knocks it back up to where it should be. That's the negative feedback part. Now, when it drops, when the heat comes on, it's going to bring the temperature up. But that temperature is not going to stop, right? That temperature is not going to stop at 70. It's going to go a little higher than that, isn't it? And it's going to go up maybe 70.5 or 71. And then that arrow at the top represents what? The heat turning off. But in your body, it might refer to a different hormone. So you might have one hormone pushing things up and one hormone pushing things down. And off we go. So this would be the set point. The normal body temperature, okay, the body temperature would stay, or the room temperature would stay in this zone, wouldn't it? So the body is going to try to keep it, or the room is going to try to keep the temperature as set as possible. Not perfectly 70, but within an acceptable range. Yes?
It's so like when you go to the doctor and they find out something wrong, are they is that what they're testing, or like they test your blood cells to find out like if you have like an imbalance, if it's like too many?
Oftentimes they are. So they are looking for imbalances, and then typically in a normal checkup, they're not going very deep. But if they see something off, then they'll do greater testing or send you off to a person who deals with hormones or other imbalances. So absolutely, absolutely. So that was negative feedback. In other words, as the temperature drops, something pushes it up, or as the temperature gets too high, something pushes it back down. The opposite of that is positive feedback. This is not as common in your body, but there are examples of positive feedback. Basically, as the value deviates from the normal value, it's actually going to snowball. It's going to get worse and worse and worse, or more and more abnormal. An example of this would be during childbirth. When the uterus begins to contract, most women will just continue that right into birth, right? The body really doesn't have a mechanism of stopping uterine contractions once they begin. So once the brain starts sending those signals down to the uterus and tells it to contract, it's usually going to go to completion. All we're going to be able to do, though, as medical scientists is do what? Put you in the hospital, give you some medications to stop it. But that's not a normal situation. So as the uterus begins to contract, it just snowballs and keeps on going. That's positive feedback. Another example would be excessively low blood pressure. And I'm going to show you this example in a picture coming up to help you appreciate this. So in this is now your blood pressure. Everything in the darker blue range would be, quote, your normal homeostatic blood pressure. And it's going to continue, up and down, up and down, up and down, as we would expect. But in this example, something's happened. There's a bleed. There's a hemorrhage. You are losing blood at a rather significant level. So you've severed an artery or had some sort of aneurysm. Something's gone wrong. And you're losing blood. Now, as you lose blood, there's less blood in your blood vessels, and as a result, your blood pressure goes down. And as your blood pressure goes down, bad things start happening. When it gets really, really low, your brain can no longer get the oxygen and the nutrients it needs. Your other organs are no longer functioning well. And basically, if we can't stop that bleed, you're going to continue to bleed out, you're going to continue to lower your blood pressure, and you're going to die. Okay? So this is an example of positive feedback. It's not a positive outcome, but it's an example of positive feedback. So as the blood pressure began to drop, it got worse and worse and worse and worse until life was no longer with us, unless something came along. Again, it's the same idea. A woman can't stop her contractions. We can't stop a major bleed. The body really doesn't have a mechanism for this. And as things begin to get bad, they get worse, right? They just keep snowballing until the end. So those are positive and negative feedback. And that's really the last of the content that you'll see mentioned in Exam 1. But I do have 4 or 5 more slides, and these are different types of imaging. Who told me they were going into imaging? Anybody here thinking about going into imaging, radiography, or something like that? So later in the course, all of you will be doing a short paper. And a short paper is basically your opportunity to learn about anything you're interested in, a surgical procedure, a medication, a disease, whatever. And you'll find 3 research articles on that topic. You'll write a paragraph about what you learned and turn it in. It's worth 50 points. I'll talk to you about it more in the course. When you're doing that literature search, you may come across references to X-rays, PET scans, CTs, MRIs. So I want you to have a basic understanding of what these procedures involve so that you can better appreciate it as you come across it. So we'll start off with X-rays. So X-ray, we've all probably had an X-ray. We're using actually high-powered X-rays. Those X-rays pass right through soft tissue, things like fat and skin. But they tend to bombard and hit denser things like bone and teeth and tumors. And the film that you see is in inverse. So the darker areas are soft tissue or air, and the lighter colored areas are the denser areas. So this is great for the dentist. This is great for looking at broken bones. This is great for looking at a tumor. A tumor would be a denser set of cells that would show up, and that's the basis of a mammogram, right? You're doing a X-ray basically of the breast, looking for a dense area of tissue. Number 2, sonography. This has come a long, long way. I really need to update my slides on this. I've said that for a couple semesters now. But basically, sonography uses sound waves, just like the Navy uses it to bounce off the bottom of the ocean to look for wreckage. And these sound waves are going to reflect off organs. This is great for looking at a fetus. This is great for looking at looking for gallstones or something like that in an abdomen. It typically was that these weren't the sharpest images, but that has really changed. With computer enhancement, now sonography is incredibly sharp. It's in color, really, really cool. The good thing about it is there's no harmful X-rays, and you can have repeated sonograms without any damage or necessary issues to the baby or to the mom or the subject. CT scans, CAT scans. You're back to using X-rays. You're using a lower intensity X-ray. You're using this in help with a computer. That's where the C part comes, computerized. And what's nice about this is that you're taking a series of X-rays, but with the computer's help, it's going to make a bunch of slices, artificial slices, coronal, sagittal, and transverse sections. And what that's going to do is allow you now to not have overlapping organs or structures. So one CAT scan, and the computer will now slice your body up into all these pieces, and you don't have to worry about overlapping structures. It's still best for hard things. It's still looking for bone and tumor type things. Versus MRI. MRI, you're no longer using X-rays. Now you're using an extremely powerful magnet. And that magnet is actually realigning the protons in your tissues and is giving you a beautiful image of soft tissues. This is the type of imaging you'd have for cartilage or something wrong with a knee or a shoulder. Also looking for tumors with an MRI. It was typical that MRIs were very claustrophobic, that they were a very closed tube. They fixed that. They now have open MRIs, but sometimes the resolution is not quite as good. So there's still a trade-off, but still phenomenal images available, computer enhanced, really important imaging. Finally, the last one today is PET scans. PET scans are using radioactive tools, and I'll describe one kind of PET scan where you use radioactive glucose. Now, glucose is sugar, and all the cells in your body are taking up glucose as an energy source. By making that glucose radioactive, you inject it into the patient, all the cells in the body will take up that glucose as an energy source. But cells that are dividing really, really fast will take up more of that glucose. Well, what kind of cells are growing really, really fast? Cancer. So this is a tool of looking for rapidly growing cells. And what you will see is that based upon the computer recognizing this radioactivity, you'll see a hot spot. So here you see a hot spot in this. It's not the greatest resolution, but you'll see a hot spot, suggesting that in this area there are cells that are growing much faster than the neighboring cells, suggesting a tumor. Now this can also be used for cold spots. If someone's had a stroke, and they've lost a part of their brain to death, or they've lost a part of their heart to a heart attack, you can do the same PET scan and now look for a cold spot, a place where there is no uptake of glucose because the cells are dead. So it's going to be used either for overactive or underactive cells. And that brings us to the end of chapter 1. What do you think? Any questions, thoughts? Chapter 1. Yes, ma'am.
Okay, so positive feedback would be like cancer.
Talk to me. Positive feedback is like cancer. Keep going.
Like a deadly thing.
No, doesn't have to be. Labor is not deadly. Right? So positive feedback simply means that as something is occurring, it is allowed to continue to completion rather than the body trying to stop it and push it back to normal. Okay? That's positive feedback. Yes?
Cancer cell is positive feedback, isn't it?
Say it again?
Isn't growth of cancer cells positive feedback? Because there is no negative feedback onto stopping the...
You could look at a growth of a tumor as being a positive feedback, I suppose. Yeah. Because there really isn't a mechanism to stop it. I guess in that way, yeah, you could think of it as being positive. Yes. Other thoughts, questions? Thank you for your questions. Yes?
Okay, so negative is like the body can stop it.
The body can stop it, and there's a mechanism by which to stop it. So as blood pressure starts to go up, there's something that pushes it down. As blood pressure starts to go down, there's something that pushes it up.
So basically, negative feedback is trying to maintain homeostasis.
There you go. Negative feedback is maintaining homeostasis, or saying it the other way around, homeostasis is maintained by negative feedback. Absolutely.
Sorry, it's probably positive, but for negative feedback, I could say it's like it's whatever's comfortable for you at the time, whether you're sleeping or working out.
Yeah, you definitely your blood pressure does not stay the same. Right? If you're exercising, clearly your blood pressure goes up, your things go up. If you're fasting, your sugar is going to go down. So there are different levels of what's acceptable, right? But when your body can no longer maintain normal, you're seeing the doctor, right? There's something wrong. So yeah, when you exercise, your blood pressure goes up. When you're at rest, your blood pressure is down. That's still all considered within normal, right? But when you no longer can maintain that normal, then we've got some issues. Question?
And it's off of hers, what she said. Positive feedback is when basically it's disrupting homeostasis.
Positive feedback is disrupting homeostasis, yes, because there's no way to get it back. So once it starts to roll, once it starts to deviate, it snowballs. Okay, good. Okay, question, one more question.
Okay, you know, you just said positive feedback is when the body can control it, but how could you explain when the uterus contracts and is able to, when the body is able to go back to maintaining homeostasis?
After completion. So the uterus goes to completion and then life is back to normal. Yeah. Okay? Now, on the first exam, I want to give you a little bit more information. Exam 1's not for 2 more weeks from today, but it says on your syllabus that it's chapter 1 and chapter 2. It does not say, and it should have said, there's another very important piece of information on exam 1, and that is the stuff you learned in lab 1. So the presentation that you had in lab 1 or will have in lab 1 on directional terms, body cavities, serous membranes, body regions, slices and planes, that conversation and that PowerPoint that was part of lab 1 is also an important part of exam 1. So exam 1 is really 3 parts. Chapter 1, done. Lab 1, almost done for all of you. And chapter 2, which is beginning today and finishing up probably on Monday. Okay, so don't forget, I'll say it again, but exam 1 covers lab 1 as well. Question?
And we are talking about exam 1 that is September 9th, right?
Yes, the 9th, Wednesday the 9th. Right, that'll be your day in this room at your regular class time. Exam 1.
And exam 2, does it include lab 2?
No, good point. Lab 1 is the only lab where it is specifically a part of your exam. Okay, more about that as we get there, but no, I'll keep you up on that. Any other questions on chapter 1? Let's move on to chapter 2, and we'll get started with this. Okay, chapter 2. This is our chemistry chapter. This is, let me, by a show of hands, how many folks here have taken chemistry 100 or 101, 109, any of the courses here at MCC? Just a few number, and that's very typical. Very few of you have much background in chemistry. How many of you had a chemistry class in high school? Okay, and I'm not going to ask for who have not. There's usually a few students who have not had any chemistry in high school, or if they did, they completely forgot it, and they don't recall anything. And maybe this makes you a little bit nervous that we're talking about chemistry here. Let me assure you that I'm only going to be introducing some basic ideas, and that you will dive much deeper in this when you take your prospective chemistry classes. But we have to understand basic chemistry to move forward. As I said to you, atom to atom, we've got to understand what atoms are. And we've got to understand how and why atoms combine to make molecules and macromolecules to really appreciate this entire atom-to-atom continuum. So I'm only going to tell you enough to make the story complete, I hope. So here's our atom-to-atom continuum. Again, we are starting here at the top with atoms and molecules, and that will be our focus in Chapter 2 at this level. Also the macromolecules. And then the organelles and the cells will pick up in the next chapter. So you know why we have to study chemistry, right? We have to understand atoms and molecules to move forward. And so this does become an important fundamental part of the introduction to AMP. Next week, our lab number 2, will basically be cells and chemistry. We're going to be looking at pH and solubility, and we'll be looking at some concepts that are included in this lecture. So this slide looks more like a chemistry or a physical science topic, but matter. All things are made of matter. So what is matter? Matter is one of those definitions I know that you learned somewhere in upper elementary, and then again in middle school, and then again in high school. And you, somewhere in your depths of your mind, you know that matter is anything that occupies space and has mass. That's a definition that should sound familiar. It doesn't have a lot of application, perhaps. Maybe you remember that, but you're not quite sure what it means. Mass refers to the amount of matter in an object. And to be honest, when I look at those two definitions, it looks like circular reasoning, right? They each define each other. Help me, help me, help me. I don't quite understand what's going on here. Let me help you with this. Now, if you walk around in everyday language, we say, how much does something weigh? What's its weight, right? What was the baby? How much does the baby weigh? How much, what's that bunch of bananas weigh? How much am I going to pay for that? That's what we talk about. What's your weight? Scientists talk more about mass. And here's why scientists talk about mass. Weight is different depending upon the gravitational pull. So if I step on my bathroom scale, it gives me a very large number, right? And I take my bathroom scale and I go up to Mount McKinley or Mount Kilimanjaro and I step on my bathroom scale. Am I going to weigh the same? No, I'm going to weigh a little less because there's less gravitational pull at the top of the mountain. And if I take my scale now to the moon and somehow position myself on that scale, I'm going to weigh a lot less, right? But if I bring my bathroom mirror with me and I look in the mirror, I'm still there, right? Nothing's changed. So weight is dependent upon gravitational force, whereas mass isn't going to change if I'm on this planet, Mars, or Pluto, or on the mountain's top. So that's why mass is actually a little bit more constant, right? And so why scientists play with mass more than they do with weight. What is the mass of that? You're going to put it on a scale, and you're going to measure it in grams, right? Or kilograms, that kind of thing. Now, what is all this mass? When I look in the mirror, when you look in the mirror and we see this mass, this body, right? We have matter. We take up space. So what is this stuff made of? Well, our body is composed of some of the elements. So when you look at the periodic table over here in the corner, or a periodic table, all those elements, hydrogen, helium, lithium, that's a list of all the elements on the earth. And if I had in my hand a chunk of pure gold, that gold is made up of what? Only gold atoms. If I had a chunk of pure carbon in my hand, that chunk of carbon is composed only of carbon atoms. Okay? So atoms are the building block for the elements that we have on the earth. There's about 112 elements. There are some newly made elements. Those are things that don't necessarily exist in their natural state on the Earth. They've been made in a laboratory. And most of those man-made elements are short-lived and really nothing that we deal with in an everyday life. Of those 112 or so elements, only 20 of them are required for life. And you've seen them on your vitamin bottle. Look at any vitamin bottle, even look at an energy drink, and you'll see many of these mentioned on there. Of those 20 necessary for life, 96% of our body is made up of 4 of them. So 96% of you and me is made up of carbon, oxygen, hydrogen, and nitrogen. That's it, right? On the black market or on eBay, our body's only worth about $6, right? If we were just selling ourselves for elements, we got a couple of gold molecules in there, we get a couple of dollars for that. But for the most part, we are made up of really cheap stuff: carbon, oxygen, hydrogen, and nitrogen. So let's understand what an atom is. Your body's made up of mostly carbon, oxygen, and hydrogen and nitrogen atoms. So I lied. It won't be the first time. I told you that the atom was the smallest thing we were going to talk about. We're actually going to break it down just a little bit more. And we will talk about protons, neutrons, and electrons, just to understand what atoms are. And if you take a physics class, those things are made up of smaller things themselves. So the logic just keeps on going. But we're just going to deal with this. An atom consists of a nucleus. When you hear the word nucleus, what comes to mind? Most of us think of a cell. And we probably think, oh, the nucleus is kind of usually described as being in the center of the cell. And the nucleus has within it the DNA. That's a simplistic view, but that's what most of us probably think about. The center of the cell has a nucleus. Atoms also have a nucleus in the center. So that's similar. And then outside of that nucleus, there's a bunch of electrons. Visually, it sort of looks like this. Now, don't get caught in this being a two-dimensional flat thing. Atoms are three-dimensional spherical beasts. And the entire sphere here, including this big blue sphere, would be the atom. In the very center of this atom, represented by the red sphere in the center, this is the nucleus. Now, to give you an idea of space that we can appreciate, I'm going to talk about my alma mater, the University of Florida. So at the football stadium, about 90,000 people. They play football down the road, right? Michigan State, Michigan. They have a football stadium. They even play football around here? Not really. You guys don't know what football is around here. But anyway, in the Southeastern Conference, where football is real, you can throw tomatoes at me later. Stadium, right? 90,000, 100,000, whatever the number is. That stadium would represent the atom. If you could, from the 50-yard line, drop down over the 50-yard line, something in the scale of a grapefruit, a tennis ball, an orange, something in that relative scale, something you could easily hold in your hands, that would represent the nucleus. So the nucleus makes up a very, very small, compact part of the overall atom. Now, inside that nucleus is where one finds, protons and neutrons. We'll talk about them in a moment. Outside, in the rest of the stadium, out in all the seats and on the field, are where the electrons are hanging out. And what we'll see in a few minutes is that the electrons can't go anywhere. The electrons have assigned seats. So they have assigned sections of the stadium to which they can hang out. So that's sort of a cartoon of an atom. It's mostly space, right? If you look at this, that blue haze is empty space. There's a few little electrons running around. So that's why mass is something that takes up space, right? Takes up a lot of space. Now, this atomic structure, what makes up the atom? Number one, the nucleus. And in the nucleus, I told you there are protons. Protons are designated as P+, because those protons have a positive charge. The number of protons in the nucleus is not random. It is very defined. Hydrogen is the first element, and it has one proton in the nucleus, always. If there isn't one proton, it isn't hydrogen. Helium is the second. It always has two protons. Carbon is the sixth. Oxygen is the eighth. So the number of protons is non-negotiable, and each proton carries with it a positive 1 charge. Neutrons are also found in the nucleus. They're marked as N superscript 0. They're neutral in their charge. They have 0 charge. They still, though, contribute to the mass weight, right, to the mass of the atom. The atomic mass, right, the mass of the atom, is a combination of the protons and neutrons. And we usually count each a proton and a neutron of having a mass of 1. So if carbon, which is the 6th element, has and always has 6 protons, and I'm telling you that there's usually also 6 neutrons in the nucleus of a carbon atom, its mass would be about 12. Now there's more to it than this, but we're not becoming chemists today. We're just kind of getting through the basics of this. Outside the nucleus, out in the blue hazy shell, are what we call orbitals, and it's out there in that cloud where the electrons hang out, and the electrons are marked as E negative. They carry a negative charge. Let's try to put this into a picture for you. In the upper left, that is I know it's very small in your handout. That represents a hydrogen atom. That hydrogen atom has, the dark center is 1 proton, and the hazy area around it is the orbitals, and there's 1 electron out there. Average carbon atom in the middle, 6 protons, 6 electrons. Oxygen, 8 protons, 8 electrons. So what you're noticing is that the atomic number equals the number of protons. The atomic number of hydrogen is what? Of hydrogen, the atomic number is 1. The atomic number of carbon is 6. The atomic number of oxygen is 8. What are you looking at? The number of protons. Number of protons. The number of protons is non-negotiable. If an atom has 6 protons in it, it is carbon. No one's doubting it. If an atom has 8 protons in its nucleus, it must be oxygen. Now, what else are you noticing? That the number of protons is balanced by the number of electrons. So, electrons are negative, and I'm telling you that all atoms are electrically neutral. That is, they always have the same number of protons and the same number of electrons. Therefore, the atomic number is the same, or is equivalent to the number of electrons. Now, that's what you would normally find in nature. You would find that atoms are electrically neutral. The number of protons and the number of electrons are going to be balanced. So that's protons, okay? So I've said to you that the number of protons is non-negotiable. It defines really what the atom is. But what about neutrons? Neutrons are a little bit different. They can actually vary in their numbers. And there are variations of these neutron numbers, and these variations are called isotopes. And I'll introduce isotopes to you. Oftentimes, isotopes are radioactive. When I mentioned that there was radioactive glucose used in a PET scan, that's an isotope of glucose, a variation of glucose with a different number of neutrons. Let me help you make a picture of this. So on this figure, there's 2 different things represented. So over here on the left, there are 3 versions, 3 isotopes of hydrogen. Now it's hydrogen. So what do we know about hydrogen? Hydrogen is the first element, therefore it has 1 proton. So all of these versions of hydrogen have 1 proton. They all have 1 proton. But, as you can see, this one has no neutron. Its mass is 1, and that's your normal type of hydrogen. But there's a variation of hydrogen called deuterium. Deuterium has the 1 proton, but also has an extra, or has 1 neutron in the nucleus. As a result, its mass is 2, deuce, so we call it deuterium. And there's another version of hydrogen where there's 2 neutrons squeezed into the nucleus, and now the mass is 3, so we call it tritium. Those are variations, isotopes of hydrogen. On the carbon side, normal carbon, the carbon you would dig up in your backyard, that carbon has 6 protons. It's carbon. It has to have 6 protons, non-negotiable. And the most common type of carbon has also 6 neutrons in it. Overall, we call this, therefore, carbon-12. But there's a variation of carbon called carbon-14. Carbon-14 must have 6 protons. It's still carbon. This version has 8 neutrons. Its mass, therefore, is 14. This is radioactive carbon. This is the carbon used for radiolabeling, for determining how old things are in the world. Okay? So that's the neutron story. Really, really important in medicine. Isotopes and imaging, very, very important about radioisotopes. Now, that's protons and neutrons, but our biggest discussion needs to be about electrons. Electrons really are going to dictate how molecules combine, how atoms do or won't combine to make molecules. So we're going to spend most of our time here talking, last 5 minutes, about electrons. In your body, every one of your cells is doing thousands and thousands of chemical reactions every second. It's an amazing process. Whenever atoms either combine, come together, or when they break apart, some sort of chemical reaction has occurred. This would be referred to as your biochemistry, right? All the chemistry happening in your cells. Where did I tell you the electrons were? The protons and the neutrons were in the nucleus. And I told you the electrons were out in the orbitals, or out in the blue hazy cloud, or out in the stadium, to make that analogy complete. It turns out that I told you that electrons cannot just go anywhere they want to. They have assigned seats. They go to particular sections of the stadium, or they go to particular what we call shells. Sort of like the seats inside, the expensive seats, and then the cheaper, nosebleed seats out further in the stadium. In chemistry, one of the rules, or one of the ideas, is that every atom wants its outer shell, its outer seats, to be full, right? Makes sense. Every concert person wants their outer seats filled, right? So we want to have the outer seats full. And if the outer seats are full, then that atom is more stable. It's just happier. We'll just put it that way for now. So let's use carbon as an example to figure this out. Carbon is the 6th element. It has an atomic number of 6. Therefore, how many protons does it have? 6. In regular old carbon, how many electrons would there be? 6. Yes? So let's build this. I'm not going to ask you to build this, but I do need you to understand this. This green circle really is a sphere. And within the carbon nucleus, what would we find? 6 protons and usually also 6 neutrons. How many electrons are there going to be? 6. They're going to be in these particular things called shells. The first shell is shown by this red shell, this red circle. This is a small shell. It is physically able to only hold 2 electrons. So we're going to put those first 2 electrons in that shell, but that shell's full. How many electrons are still left? 4. We got to find a home for them. So now we build a second series of seats. And in that shell, it can hold a maximum of 8. And so we put our 4 electrons there. Is carbon happy? No. Carbon wants to have 8. So it means it wants to gain 4 more electrons. Or it could lose 4 electrons. And when you empty the outer shell, it's like you erase it. It's gone. And if you erase the outer shell, it's okay. That's also happy. The outer shell is now filled. This is why we are said to be carbon-based life forms, right? Carbon is a fantastic tinker toy. It holds our biochemistry together because it has the flexibility of gaining as many as 4 electrons or losing as many as 4 electrons and becoming the basic tinker toy of our biochemistry. So the inner shell is shown there, the outer shell is shown here. So this idea of which atoms can combine. Chemical bonding. And there's 2 different kinds here. There's 2 basic kinds of chemical bonding. One is ionic, the other is covalent. in this situation, the electrons are either going to be transferred or they're going to be shared. And let me show you, we can get through this and then we'll be done. Show you a couple of different models of this. Ionic bonds are when the electrons are completely lost or completely gained. The example of this is going to be sodium chloride. This is the example I'll test you on. This is the example you'll read about and do problems in your pre-lab number 2. So it's not like a chemistry class where I'm suddenly going to throw something you've never seen before and ask you to figure it out. I want you to understand sodium chloride. Here's the story, and I think we'll stop with this when I finish this slide. So sodium chloride. Sodium, I'm telling you, is the 11th element. Therefore, it has the atomic number 11. How many protons? 11. How many electrons would you normally find in sodium? 11. Okay? Now, let's think about where would those electrons be. First shell, 2. Second shell, 8. That's 10. There's an extra electron that needs to go all by its lonely self in the outer third shell. So what does sodium want to do? Click it out. And now, when that outer shell is empty, now we go back to the second shell and we say that it's full. Now sodium is happy. So what we see is that sodium desperately wants to lose an electron. Chlorine is a perfect partner. Chlorine is the 17th element. Therefore, 17 protons and 17 electrons. Where are those 17 electrons? First shell, 2. Next shell, 8. Third shell, 7. That third shell also holds 8. So what does chlorine desperately want to do? Take one. So sodium becomes the perfect partner. So in this situation, what happens? Sodium loses an electron and gives it, transfers it all the way over to chlorine. As a result, sodium now still has 11 protons, but it has only now 10 electrons. If you look at those overall charges, sodium now has an overall plus charge, Na+. We call that the sodium ion. Chlorine gained that electron. It now has 18 electrons balancing by 17 protons. It now has an overall negative charge. Chlorine ion, -1. And these little sodium positives and chlorine negatives make little magnets. And these little magnets come together in a crystal-like form to make this tasty thing called sodium chloride. Okay, in nature, sodium's a metal, and chlorine is a gas. And they come together to make sodium chloride that we have in our salt shaker. So that is the example of ionic bond that I want you to know about. I'll pick up with that. I'll start that story again. Now, before I see you again, what are you going to do? Mastering? Start getting on pre-lab number 2. If you haven't had pre-lab 1, but start working on pre-lab 2. Start working on homework for chapter 1. Take a look at that dynamic study module for chapter 1. Email me if you have any concerns or problems. Come see me if you have any specific concerns, and pick up an honors syllabus if you're interested in reviewing that.